Hey learners, welcome back to Constant Learners. Today we are exploring another crucial concept in relational algebra, set difference operation. It's a fundamental operation, so let's dive right in. Let's start with the basics first. Set difference operation in relational algebra is equal to set difference in set theory. Okay? To illustrate this, let's take two simple sets. Set A has the elements 1, 2, and 3, and set B has the elements 2 and 4. Now, if we take the difference of these two sets, that is A minus B, what do we get? Now, see, this 1 is present in A, but it is not present in B, right? So, in A minus B, this 1 will be present. This 2 is present in set A as well as in set B. So, this will get cancelled. This 3 is present in set A, which is not present in B. So here we will have 3 as well. All right. So the set difference A minus B is equal to the elements that are present in A but are not present in B. All right. Now, since we're talking about relational algebra, we'll be working with relational databases. That is, where the data is stored in the form of organized tables. For the set difference operation, we need two sets, or in our case, we say that we need two tables. The purpose of this operation is very straightforward. We use it to find the tuples or rows that are present in one table but not in another table, right? Now, since we're using two tables, this makes it a binary operator, right? So set difference is a binary operator and it is denoted by the minus sign. All right, I hope this basic is clear. Now we'll discuss 3 examples to understand the set difference, and one will be homework for you to solve by yourself. Let's begin with the first example. Here we're using two simple relations, relation A, which has the column name, and relation B, which also has a single column name, right? Now, relation A has names Alice, Bob, Charlie, and Emma. And relation B has names Bob, David, and Noah, right? Now, what will the set difference relation A minus relation B give us? Now, here in relation 1, we have the name Alice. So, it is present in relation A, but it is nowhere present in relation B. So, Alice will be present in the output relation. Next, we have Bob. So, Bob is present in relation A as well as in relation B. So, this will get cancelled. This will not be present in the output. Next, we have Charlie. Charlie is present in relation A, but it is not present in relation B. So Charlie will be present in the output table. Then we have Emma. Emma is present in relation A, but not present in relation B. So Emma will be present in the output relation, right? So output will be a table with Alice, Charlie, and Emma, because these names are present in relation A, but are not present in relation B. And we are taking relation A minus relation B, right? So this is our output table. I hope that this was clear. Very simple, very easy. Now, let's take a little complicated example. For the next example, we have a college database with tables. So these are tables, students and project. And the columns are, for the students table, the columns are student ID, name, program, enrollment date, department, and status. And for the project table, the columns are student ID, name, project title, start date, department, and project status. Now, we need to write a query to list the student IDs and names of all the students who are enrolled in a master's program but are not currently working on any projects. So this column, the students column, gives us all the students who are enrolled in the master's program. All right. And the project table gives us the names of all the students who are working on some kind of project. Now, we need the student IDs and names of all the students who are enrolled in the master's program but are not working on any project, right? So, how do we write the query for this? Now, see, we need the columns. So, in the previous videos, we've discussed that if we need the columns, we use the projection operation, that is pi. All right. Now, which columns do we need? We need the student ID, that is STU underscore ID. And the second column that we need is the name. So these two columns have to be projected. But do we need the entire columns? No. we need the students who are enrolled in the master's program. So these two columns are from the students table, but we need to remove the students who are working on the project. So we are going to use the set difference, and again we are going to remove the student IDs as well as the names of all the students who are working on some kind of project. All right. So this query will give us the student ID and the names of all the students who have enrolled in the master's program but are not working on any project. All right. So these are the names of all the students who are working on a project, and these are the names and IDs of all the students. So we are subtracting the students working on a project from all the students, and this will give us the required output. All right, so here we have the tables. This is the students table and this is the projects table. Now in this case, 101 Emma is the student enrolled in the master's program, but is she present in the projects table? No. So she will be present in the output table. Then 102 Liam, he is present in the project table. That means he's working on a project. So this person will not be present in the output table. Then we have 103 Noah. So Noah is also present in the project table, so he will also not be present in the output table. Then here we have 104 Olivia. So 104 Olivia is not working on any project, so she will also be present in the output table. And here we have 105 Ava. 105 Ava is also not present in the project table, so she will also be present in the output table. Let's see what our output is. All right, so we have 101 Emma, 104 Olivia, and 105 Ava. All right, so from the list of all the students which we can find here from the students table, we need to remove the names of all the students who are working on some project. All right, and the students who are working on some project can be found from here, that is in this table, right? So if we use the set difference to subtract these students, that is students in the project table, from this table, from this list, then we get our desired output. All right, I hope that this was clear. For the next example, we have a hospital database with tables. Tables here are admissions and procedures. Admissions table has the attributes or columns as patient ID, name, admission date, department, room number, and status. And procedures table has columns patient ID, name, procedure, procedure date, department, and outcome. Now we need to write a query to list the names of all the patients who have been admitted in cardiology department but have not yet undergone any procedure. So this goes a step further. All right, this query goes a step further, a little more elaborate than the previous one. So in this case, first we need to find all the patients who are in the cardiology department, and then we need to remove the patients who have not yet undergone any procedures. All right, and in this case, we only need the names of all the patients. All right, now the list of patients can be obtained from these are the two tables, admissions and procedures. So list of patients can be obtained from the admissions table, right? But here we have a condition that we need the patients in the cardiology department only. We are only talking about the patients who are in the cardiology department, right? So first we need to select these rows, that is this row, and this row. So how do we select the rows? Using the select operation, right? Select operation selects the entire row depending on the required condition. So for select operation, we use sigma. All right. So sigma. Now what are we selecting? We are selecting department is equal to cardiology. Okay. We need department is equal to cardiology. Now from which table are we selecting this? From the admissions table. All right. Now, do we need the entire rows here? No. We just need the name column, right? And when we need the column, we use the projection operation. So here, furthermore, we are going to add pi and we need the name. All right. So this will select all the patients who are in the cardiology department in the admissions table, and this will give us only the names of those patients. All right. From this, we need to remove all the patients who have undergone the procedure. We need the names of the patients who have not yet undergone any procedure. Means those whose procedures have not started yet. We need those patients, right? That means we need to remove the patients who have started the procedures. So here we get the names of all the students who have started the procedures. Now, if you see here also we need the patient from the cardiology department only. So first we need to select this entire row. Then we need to select only the name from this entire row. So again, we start with sigma. Again, we will select the patients from the cardiology department. So we select the entire row of patient who is from the cardiology department. But now the table is procedures table, right? But here also we only need to project the name. So we take the name. All right. Now, so this patient has started the procedure, but we need the patients who have not undergone any procedure. So this entire query will give us the names of all the patients. This entire query will give us the patient who has started the procedure. Now, if we remove the patients who have started the procedure, we will get the patients who have not yet undergone any procedure, and that too from only the cardiology department. I hope that you've understood what we are doing. Now, here we have John Smith. See, the first query, that is this query, will give us these three patients. That is John Smith, who is in the cardiology department, Emily Davis in the cardiology department, and Sarah Brown also from the cardiology department. And the second part of the query, that is this one, is going to give us only this patient, Emily Davis from the cardiology department. Now, if we use the set difference for both of these queries, we will get, see, John Smith is present in this table, but he is not present in the procedures table. Emily Davis is present in this table, and she's also present in this table. So Emily Davis will be removed from the output because she's already started the procedure. Sarah Brown is present here, but she's not present here. That means she will also be present in the output table. So there are two patients in the cardiology department, John Smith and Sarah Brown, who have not yet started any procedures. Okay. So the output table will have two names, John Smith and Sarah Brown. All right. I hope that this example was also clear. Now for the next example that you have to try and do it by yourself, we have a library database. Here we have two tables, books table and the checked out table. We have columns as book ID, title, author and genre. And here we have book ID, title, member ID, checkout date and due date, right? Now you have to list the names of all the books of the genre fiction. So we need to select, this is the first condition, that we need to select all the books from the fiction genre that are available in the library. Available in the library means that have not yet been checked out, all right, and are not currently checked out, right? So first we need to use the select operation to select all the books that are in the fiction department. Then we need to project the names of all the books, and then we need to select the books again from the checked out department and remove the books that are present in the checked out department from the total books present in the library. All right. So these are the columns. Here we have this 1, 2, and 3 books in the fiction department. So first we will select these 3 rows. Then we will project the names of these 3 books. Then we will look at the checkout table and we will remove the books present in this column from the books that we have selected from this column. That is 1, 2, and 3. All right. So I hope you can write the query by yourself for this one. Share the answers in the comment section. If you're unable to do so, kindly look at the previous examples once again. If you still can't do it, you can check the pinned comment or ask your doubts through the comments. All right. And that's the set difference in a nutshell. It's a simple yet powerful tool in relational algebra. Stick around because in our next video, we'll dive into more complex topics to really solidify our understanding of relational algebra and eventually of SQL. All right. Thanks for watching, constant learners. Don't forget to like, subscribe, and hit that notification bell so you never miss an update. All right. See you next time. Thank you for watching.